the last class we have seen about open loop control system. We have seen the demerits of the open loop control system, that however intelligent your open loop controller is, but it is not having any knowledge about the change in disturbance. So if due course of time disturbance changes, your controller will not be able to compensate for that particular change in disturbance. Okay, whatever your controller whatever knowledge your controller is having in open loop control is just the information about your commands. But one more thing is that one way to give the knowledge about disturbances to the controller is that directly provide the knowledge about disturbance to the controller. But since disturbances are relatively random in nature, so you can't provide the knowledge about the disturbances in advance to the controller. So what we do, we apply another scheme, means let the disturbance react to your process or plan, and this reaction will be reflected into response variable or control variable, and we will try to measure or we will try to feed it back, means the value of control variable, to the controller, so that whatever the change disturbance have caused to the response variable will be also available to your controller. So we are going to apply one more feedback sensor in this. Okay, so your feedback sensor is going to sense your control variable, and accordingly it will give feedback to your controller. Now what the controller will compare your control variable with the command signal and generate an error signal, and this error signal is further utilized by your controller to generate a control signal, and this particular control signal is used to manipulate the value of your response variable to bring the error zero. Okay, means so that your response variable will be equal to your set point. Okay. This particular scheme is known as closed loop control system. Okay. Now coming to that, some advantages. Number one advantage is that accuracy. You know that because here your controller is relatively more intelligent than the previous one. It is having a knowledge. It is having indirect knowledge of disturbances with the help of your response variable or control variable. So it will be more accurate. It can also tackle your change in disturbance due course of time. Robustness. By saying something is robust, it means it can tolerate the changes. If I am a robust system, I am not going to be affected by the external environmental changes. So this is relatively robust because change in disturbance is now captured indirectly in terms of control variable, and it is being fed back to the controller. So accordingly your controller can generate your command signal. Reliable. Reliable means it is trustworthy. Means it is relative to your open loop control system. It is more reliable. Means you can rely on the value of you can say control variable or response variable. Okay. What are some limitations of this closed loop control system, or you can say the sum of the disadvantages of this closed loop control system is that since one additional component is added, like you need to add some feedback sensor and some analog to digital converter according to the need, or digital to analog converter. So your system is going to be more complex, and due to addition of these additional components, it will also derive more power. And due to presence of feedback sensor, you know that the nature of the feedback sensor is to generate noise. So to remove the noise, you need also some low pass filter and somewhat like this. So some additional means it will increase the number of components, and of course it will be less stable. Though you have seen in the experiment, or you will see in the experiment later on, this point will be clear in the lecture also. Okay, how it gets less stable compared to your open loop control. Means even a stable closed loop control system, a stable open loop control system, if you provide feedback to it under certain circumstances, it may become unstable. Well, coming to some of the example, very familiar example is air conditioner, because here feedback is there. You provide some set point temperature, and accordingly a thermostat is there, or thermal sensor is there. It senses the temperature of room, and accordingly it or generate an error signal, and this controller utilized to generate a command signal which manipulate the value of this your room or you can say your process or plant. Okay. Second example you can take is a electric geyser. This was of course better than the previous one, previous version of immersion, right? Because here there are feedback sensor, temperature feedback sensor, which senses the temperature that after if the value of your water inside the tank crosses your set point, it cut off the power supply. Okay, so suppose you have set the value of geyser at 60 degrees centigrade or 80 degrees centigrade. After that, the power supply will be cut. So it is a closed loop control. Some robotic application. Every robotic application use some types of feedback. Okay, and not only if you are talking about the feedback controller, you should not just give the example of such complex system. It can be in some cases can be as easy as your toilet flush. Toilet flush is a mechanical type of feedback controller because the float is there. When you switch the button, water comes out, and after a certain level, the float goes up and it cut off the water supply. Okay, so it was also a even toilet flush is also a example of you can say closed loop control. And rather than that, all industrial processes use one or another type of closed loop control, and almost all application, whatever you see, are mostly in industry or in air traffic application or for scientific application are of closed loop control. Okay, that's why we will focus more on closed loop control. Well, coming to the design step, I have already discussed that you as a control engineer, your job as a control engineer to analyze the stability of the controller and to design the controller. So what are the various methodology available to design the controller? Means first we have seen the what are the various configurations. Means open loop control and closed loop control are the two configurations in which you can control your system. Now we are going to focus on the closed loop control because when you design an open loop control, you will not control better. You will not be able to control better because if the disturbance changes in due course of time, your controller will not be aware of this change in disturbance. So we will focus more on the closed loop control. Means in this course, or you as a control engineer is going to design a closed loop control system. So what are the various methodologies to design the closed loop control system? First one is experimental approach. Suppose based upon the previous experimental knowledge of the process or plant, install a controller, and controller is having some parameters which can be changed or tuned. Okay, so I will go online and change the certain value of the parameters, and accordingly I will try to see the effect of this change in the value of controller on the response variable and control variable. I will continue to do this process till you can say the desired result is obtained. Till I will be satisfied with okay, this much error I can tolerate, or I am satisfied with this result of your control variable. So this particular method is widely used in the area of process control. So you will also read when you will read in your third year about process control. So some Ziegler-Nicholas methods are there, and some other methods for tuning is there. And in experiment also, what if you are do the PID controller, you will also somehow you will apply this method of controller tuning. Okay, so this is a simple approach. This is you can say ad hoc approach, because for complex system it is not going to work because tuning will continue for infinite time. Suppose 3 or 4 variables are there, and to adjusting these all 3 or 4 variables to get the desired output is a very difficult task. So this work fine for the simple system, and where the requirements are not so hard to meet. Means in process control, okay, if some delay in the pipeline will be there, it can be tolerated. But in air traffic control, it can't be tolerated. In a delay of a fraction of a second can lead to a serious accident. Okay. So for the system which are more complex to be tuned, or where the demands on the response or control variable are too hard to be met, we shift from the ad hoc method of experimental approach to model-based or analytical approach. Here, what we do means जैसे आप दुर्गा पूजा मनाते हैं तो आप एक मॉडल ही बनाते हैं कि दुर्गा की मूर्ति है तो उसको ही भगवान मान लिया, उसको पूजा कर लिया, है ना, वो भगवान तो है नहीं, ऐसे ही करके वो somewhat like वो represent कर रहे हैं. तो model is something which is going to represent something else. So what you do, you will capture the dynamics of the system and represent this dynamics of the system in suitable mathematical form. This mathematical form may be a differential equation or transfer function or a state variable method. Later we will see that we can also get transfer function from the differential equation itself. So this method is basically when you have derived the mathematical model, you can work on the mathematical model, you can analyze the mathematical model to know the characteristics of the system, and then after that your experiment on software and whatever outside the plant, you can install your controller. After final finished product, you can directly install. Okay. So this is your model-based or analytical approach. Third one is your knowledge-based approach. This is actually now actually the experiment are being done on this. This is in area of this is under active you can say under actively being used. This is one of the hot topic nowadays. Okay. So what you do in this particular case, you put an intelligent operator, means something like machine or some software you put based upon some guideline and rules. Okay. And you keep on changing these rules to meet the your response variable under control. So fuzzy logic, artificial neural network, support vector machines are some methodology which are nowadays being used exhaustively to achieve this you can say knowledge-based approach. This particular approach is also alternatively known as machine learning. You might have learned seen this particular word. फॉरन में एमएस होगा मशीन लर्निंग पे काफी होता है. ठीक है. Well, so this was overall I have talked about the various schemes level, means various configuration of the control system and various schemes or various approach level to design a controller. Now what we will do in this particular course, we will focus on model based approach, means we will try to derive the model, or you can say the transfer function model. This is we will try to derive the mathematical model in terms of differential equation, or later on after converting the differential equation into you can say after performing Laplace transform, you can get the transfer function model. Whatever it may be, whether it may be differential equation or transfer function, which is a sort of mathematical model. So what we will derive the mathematical model. There are two ways you can say the mathematical model can be derived. First one is you are going to apply, suppose you have given a system, you will apply the laws of physics. Based upon the laws of physics, you will write some differential equation. Then you will take the Laplace transform of that differential equation and you will define the transfer function. In the next lecture, in just the next session, you will see that what is the transfer function actually. Suppose your system is too complex to analyze or to apply for you to apply the laws of physics. Means there are many components. Suppose there is a simple circuit or mass spring damper system is there, you can apply the laws of physics. You have solved your enough mechanics in your class 12, or it is suppose it is a simple system like simple electrical system like which consists of simple inductor or resistor or and capacitor in series along with a voltage source. Then also you can apply your laws of physics you have already seen in your cyclical system course. Means you can apply Kirchhoff's law, voltage law, Mass loop, and all those things, and you can analyze your system. But suppose a overall system is too complex, so that you cannot apply, you are not able to apply the law of physics. So what you will do? You will go for experimentation approach. In experimentation approach, what you will provide? You will treat whole the system as a black box. Okay. You will have a certain state of input. You will provide the input and notice down the output. And based upon a certain method which you will learn in the later classes, you can derive your transfer function and you can derive the input-output relation. This particular input-output relation to get your model, mathematical model. Means you are not going to apply physical law, just based upon the input-output relationship you will derive your model. Okay. And this particular model is known as actually in literature they say that this is system identification. Well, so in the era of 1900 to 1940, what comes some methods of design and analysis were developed. Means what I am talking is about mathematical model now. Okay, like board plot, Nyquist plot, polar plot, root locus. Afterward, 1960 onward, 1960 onward, due to meet the demands of air traffic control, method of state space analysis was developed, and this, since it was relatively new with respect to this particular method, which was developed in 1900 to 1940 or up to 1960, you can say up to 60. Okay, so we have named it as a modern control system. Modern control system, which you will study in your third year. Since I have named, or we have named this particular method of state space analysis as a modern control system, so whatever we have invented earlier was known as classical method of design and analysis. Classical methods. Okay, classical methods of design and analysis. In basics of in this basic course of control system, whatever you will read the classical methods of design and analysis. One can have a doubt that why. One can have a doubt that आप जाके पीछे खड़े हो जाइए. Go on. Stand up. And keep on standing. You also. Okay. क्या नाम है? रोहन. 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 और आपका? हाँ. खड़े हो. So, since it was invented later, that's why we are going to say that it is अलग-अलग. एक इधर एक इधर. That's why we are going to say that this is a modern method of design and analysis, and this is classical method of design and analysis. One can have doubt that okay, while the modern method of design and analysis, it means that a modern control system has been invented. So why we are going to read the classical method of design and analysis? It is a normal question or general question. But the thing is that almost 75% or more than 75% of industries nowadays even use classical methods of design and analysis. And this particular modern control system, or you can say the state space methods of design and analysis, is used in a particular area, that is the area of air traffic control. Okay, that's all. So now we are going to discuss about impulse response model or transfer function. Okay, so what is the transfer function? We are going to start our course of classical control system with the definition of transfer function. First of all, you should note it down that this particular method is used for linear time invariant system. By saying that this particular system is linear time invariant, I mean to say that the characteristics of the system is not going to change with time. Though the input can change, the output can change, but the components of the system should not change with time. So this particular methodology will be applicable for this such type of system where the components, say one of the component is their inductor or some capacitor is there, it should not change with time. Then only you can apply your transfer function model or impulse response model. Second, this particular method is defined under two conditions. Number one condition is that this is defined only for a relaxed condition. By saying that your system is relaxed, I mean to say that there is no storage of energy in any part of the system at initial time. Okay. Suppose you are having a simple system consisting of an inductor and capacitor and one resistor along with a voltage source. Then when you are going to start your analysis at t is equal to 0, there should not be any current through inductor and there should not be any voltage across capacitor, because you know inductor can store energy as a half Li square, that is in terms of its magnetic field, and your capacitor can store energy in terms of electric field as half C V square, where V is the voltage across the capacitor. So energy storage should be 0 at t is equal to 0. Then only you can apply this particular method. Okay. Secondly, this is only input-output relationship. Means whatever be the input, this particular approach will give you the output. Means it will not give any relationship or any information about the states of the system. No information about states. What I mean to say is states are actually, for the time being, you can consider that the energy storage element or components in your system are the states of the system. So if there are two energy storage elements, you can have your system is having two states. Okay. Now, what you will do in modern control system, we represent our system is somewhat like this. Means you can have multiple input and multiple output. Okay, and these are the states. Means at any time current through inductor, voltage across capacitor. Suppose if you are going to take this system, your inductor, or you can say one is resistor, and here it is capacitor, and here voltage Vt, and here it is Vct, and here L. This is I. So you are going to say this is the value of I and Vct will keep on changing with time. You know this. Okay. So we are going to say sorry, not it is not Vct. It is R. This is C and this is your Vct. So value of this Vct means voltage across capacitor, and current through the inductor will keep on changing with time. But this transfer function model will not be able to give this value at any time after t is equal to 0. At t is equal to 0, it should be 0 again. Okay. But even after t greater than 0, this transfer function will not provide any information about this. This I am going to say that it is one of the states. Say you can say x1 t and Vct. We are going to say that this is another state. So a system can in general have n states. Okay, and n number of inputs and n number of outputs simultaneously. But in transfer function approach, what we consider, we are not going to consider these states. We have already assumed that the states of the system is 0. Means what I am going to say that you have to remove this part in transfer function approach. Means x1 0 or x2 0 in general up to xn 0 are 0. So this part, these arrows will be removed for your system. What you will left with that inputs and outputs. And in most general cases, we will take single input, single output, because later on you will come to know that your transfer function model cannot work simultaneously with multi-input, multi-output system. Okay, so this your transfer function model, you can define your transfer function just for single output, single input, single output system. So what you will get some block diagram like this. Okay, only one input, so I am going to say it is ut, and only one output, I am going to say this is y. For this basic course, rather than using this notification, this symbol ut and yt, I will use rt for input and ct for output. And what I will say, this block I am going to say this is impulse response.